Good day, senior high school students, and welcome back. I am your online math teacher, Ma'am Karim. I am so glad that you are here to join us in discussing the lesson in statistics and probability. Our lesson today is all about random variables and probability distribution. For the objectives, first, illustrates a random variable. It can be discrete or continuous. The second distinguishes between a discrete and a continuous random variable. Third, finds the possible values of a random variable. And last, illustrates a probability distribution for a discrete random variable and its properties. In this lesson, we're going to define the following mathematical terms. The first one is variable. What is a variable? It is any information, attribute, characteristics, number, or quantity that describes a person, place, event, thing, or idea that can be measured or counted. Example, a person's hair color is a potential variable. For one person, it can be black. For another person, it can be blonde or gray or any other color. Another example of variable is number of students. Variable can be qualitative or quantitative. In my example, a person's hair color is a qualitative variable, and the number of students is an example of quantitative variable. A quantitative variable can be either be discrete or continuous variable. Discrete variable is a quantitative variable whose value can only be attained through counting, while continuous variable is a variable that can assume an infinitely many uncountable real number of values. Examples of discrete variable and continuous variable. Under discrete variable, we have number of students in a class, number of chairs inside the classroom, number of apples on the table. The examples under discrete variable can only be attained through counting. Say we have 50 students in a class. There are 10 chairs inside the classroom. There are 3 apples on the table. While continuous variable, we have here speed of a car, amount of electricity consumed, area of the basketball court. Continuous variable can only be attained through measuring using a device or instrument. It can be in the form of decimal or fraction. The next one is random variable. It is a variable whose value dependent to the outcome of a well-defined random event or experiment. For example, tossing 3 coins. Determining the number of heads is an example of a random variable. A random variable can be either discrete or continuous. What is a discrete random variable? In an experiment, the outcome is said to be discrete random variable if the experiment has only countable or countable infinite number of outcomes. Example, the number of arrivals at an emergency room between midnight and 6 a.m. In this event, the number of arrivals is an example of discrete variable. So this is what we call discrete random variable. How about continuous random variable? In an experiment, the outcome is said to be a continuous random variable if an outcome can take an uncountably infinite number of possible outcomes within a specified real number interval. Example, the temperature of a cup of coffee served at a restaurant. In this event, the temperature of a cup of coffee is an example of continuous variable. Therefore, this statement is an example of continuous random variable. Let's consider all the possible outcomes in the game rock, paper, scissors. We have here player A, player B, and we're going to identify the winner. All the possible outcomes are here. If player A pick rock, player B pick rock, then we have a draw. If player A pick rock and player B pick paper, the winner is player B. If we have rock, scissors, the winner is player A. Paper, rock, the winner is A. Paper, paper, we have a draw. Paper, scissors, the winner is player B. Scissors, rock, the winner is B. Scissors, paper, the winner is player A. And if we have scissors, scissors, then we have a draw. Since we have identified all the possible outcomes, the mathematical term of that is sample space. It is the set of all the possible outcomes in an experiment. So here we have rock, 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 paper, and so on and so forth until scissors, scissors. We can write the sample space as a set. Let's say the name of the sample space or the name of the set of all the outcomes in playing rock, paper, scissors is set A. So you can write the sample space as A is equal to, we have here the braces. We have the first outcome, we have the rock, rock. The second outcome, we have the rock, paper. From the table, we have rock, scissors, paper, rock, paper, 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 scissors, scissors, rock, scissors, paper, and then scissors, scissors. So this is on how you write sample space. Another term, possible values of a random variable. These are the values that are obtained from functions that assign a real number to each point of a sample space. So from the sample space in our previous experiment, we have the rock, paper, scissors. We have the sample space at A. All the outcomes are here. If you're going to assign possible values to the sample points in getting a rock or in determining the number of rock, so from the sample space, it can have, or we can have two rocks in one outcome. We have rock, rock. There are two rocks. We can have one rock from the sample space. We have here rock, paper. We have the rock, scissors. We have the paper, rock. And then we have the scissors, rock. And then we can have no rocks at all or zero. That is from the outcome paper, 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 scissors, scissors, paper, scissors, scissors. So from here in the sample space, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 outcomes. So the possible values in getting a rock are 0, 1, 2 in getting the number of rock. The next one is the probability distribution function. It is a function p of x that shows the relative probability that each outcome of an experiment will happen. Probability distribution function is denoted by p of x. From our previous event or random variable, that is getting the number of rocks, we have here R as rock, P as paper, and S as scissors. We have the possible values of a random variable we have identified, 2, 1, 0. Let X be the number of rocks or the possible values of getting the number of rocks. We have 0, 1, 2. And then P of X as the probability of getting the number of rocks. We can write our probability distribution function as P of X equals 4 over 9 as the probability. If you're going to get 0 rock or no rock, we have here 1, 2, 3, 4. From this given in the sample space, there are 4, which has no rock at all. 4 out of how many outcomes all in all are there? There are 9 outcomes. So this is the probability. In writing the probability, it can be in a fraction, decimal, or in percent form. In this example, we're going to use in a fraction form. So here, if your x or if the value of x or the assigned values for the random variable in getting the number of rocks, if we have 0, then the probability is 4 over 9. If we have 1 rock, 1, 2, 3, 4, there are 4 out of 9. 9 is the total number of outcomes. If we have 2 as the number of rocks, we have 1 over 9. There's only one outcome out of 9. So this one is the probability distribution function. P of x is equal to 4 over 9 if x is equal to 0, 4 over 9 if x is equal to 1, and 1 over 9 if x is equal to 2. Discrete probability distribution. It is a table of values that shows the probability of any of the outcomes of an experiment. From the probability distribution function, all you have to do is to transfer all the numerical values here in the probability distribution function to a table of values. So etong x, that is the number of rocks. We have here 0, 1, and 2, number of rocks. And P of x is the probability in getting the number of rocks. So that is in the fraction form. We have 4 over 9. If we have 0, if we have 1 rock, we have 4 over 9. And if we have 2 rocks, we have 1 over 9. We have to take note that the sum of the probabilities or yung P of x of a discrete random variable is always equal to 1. Let's go back to the previous table. We have here P of x as the probability in getting the number of rocks. We have 4 over 9. If we have x equals 0, 4 over 9 if x is equal to 1, and 1 over 9 if x is equal to 2. If we're going to add all the values or all the probabilities, that should be always equal to 1. So 4 over 9 plus 4 over 9 plus 1 over 9, that is equal to 9 over 9. 9 over 9 is equal to 1. Therefore, that is true, that the sum of the probabilities of a discrete random variable is always equal to 1. Let's have another example. Suppose 3 coins are tossed. Number 1, we're going to write its sample space. Number 2, assign possible values to the sample points in getting the number of tails. Number 3, we're going to write a probability distribution function in getting the number of tails. And number 4, we're going to construct its probability distribution in getting the number of tails. Let's have first number 1. Write its sample space when you toss 3 coins. Let's say we have coin 1, coin 2, and coin 3. These are all the possible outcomes. If you're going to toss 3 coins, it can have an outcome. It can be coin 1 head, coin 2 head, coin 3 head. It can be coin 1 head, head, tail. It can be the possible outcome, head, tail, head, head, tail, tail. It can be tail, head, head. It can be tail, tail, head, tail, head, tail, and then can have all tails for coin 1, coin 2, and coin 3. If we're going to write that using or in the correct form of a sample space, let's say we have H for head and T for tail. Let's name the sample space as set A as the set of outcomes in tossing 3 coins. So that would be set A is equal to open and close braces. We have all heads, head, head, tail. The third outcome can be head, tail, head. Can be head, tail, tail. Tail, tail, head. Tail, head, head. It can be tail, head, tail. And the last outcome, it can be all tails. So this set A is your sample space in tossing 3 coins. All in all, there are 8 outcomes. The second one, we're going to assign possible values to the sample points in getting the number of tails. From our sample space, we have A, that is equal to 8 outcomes. If we're going to determine the random variable, which is in this case, the number of tails, we can have 3 tails in the set A. 3 tails. In one outcome, there are 3 tails. If there are 2 tails, there are 3 outcomes. Per outcome, there are 2 tails. There is also 3 outcomes given that there is only 1 tail. And we have also 0 tails, 3 heads. So the possible values in getting the number of tails are 0, 1, 2, 3. In writing the probability distribution function in getting the number of tails, considering the possible values 0, 1, 2, 3, we can have the probability distribution function P of x as our symbol for the function that is equal to the first function given that there is 0 tail. If x is 0, then the probability is 1 over 8. How come na 1 over 8? 0 tail. So there is only one outcome out of 8 outcomes. So 1 over 8. If your x is 1 or 1 tail, there are 3 outcomes out of 8. So that is 3 over 8. If x is 2, then there are 1, 2, 3. There are 3 outcomes out of 8 outcomes. And if the number of tails is 3, then there's only one outcome. That is 1 over 8. 3 tails, 3 T's, and 0 tails, there are 3 heads. In constructing the probability distribution in getting the number of tails, that is, you're going to consider the probability distribution function. Let x be the number of tails and P of x be the probability in getting the number of tails. All you have to do is to transfer the possible values of the random variable and the probability to the table. So x, we have 0 tail, 1 tail, 2 tails, 3 tails. And its probability P of x. For 0 tail, we have 1 over 8. 1 tail, 3 over 8. 2 tails, we have 3 over 8. And 3 tails, we have 1 over 8. Now, it's your turn. Consider a basketball team will play for 3 consecutive games. Number 1, you have to determine the sample space. 2, assign possible values to the sample points in getting the number of wins. 3, write a probability distribution function in getting the number of wins. And number 4, construct its probability distribution in getting the number of wins. Now, if your answer is this, then your answer is correct. This is the possible outcome, all the possible outcomes from game 1, game 2, game 3. 3 wins, win, win, lose, can be win, lose, lose, win, lose, win, or it can be 2 loses and 1 win. It can be lose, win, and win. It can be lose, win, and lose. It can be 3 losses. So for the sample space, W and L, or W for the win and L for lose. So let's name the set or the sample space as set A. There are 8 outcomes all in all. For assigning possible values to the sample points in getting the number of wins, from the outcomes, you can have 3 wins, you can have 2 wins. There are 3 outcomes here. If there are 2 wins, there is 1 win from the outcomes. There are 3 outcomes. And 0 wins, we have 1 outcome only. So all in all, there are 8 outcomes. The possible values in getting the number of wins are 0, 1, 2, 3. Those are the values of x for the probability distribution function in getting the number of wins. So here we have P of x equals 1 over 8. This is the probability distribution. If x is 0, 3 over 8, the probability if x is 1, 3 over 8 if x is 2, and 1 over 8 if x is 3. X is the number of wins. For the probability distribution, all you have to do is to transfer all the values in the probability distribution function to a table. The values of x, these are the number of wins. We have 0 win, 1 win, 2 wins, and 3 wins. For the P of x, that is the probability in getting the number of wins. For 0 or no wins, we have 1 over 8. For 1 win, we have 3 over 8. For 2 wins, we have 3 over 8. And 3 wins, we have 1 over 8.